Now we're going to be working on a hypothesis test about a mean, and in this particular case it will only be for problems where the standard deviation is known, so the population standard deviation, sigma. Keep in mind, remember, there are cases where it's been constant for such a long period of time, it can be considered known. Now when it comes to doing a hypothesis test, there are three different methods that can be used. The first method, and the first one we're going to look at today, is called the traditional method. And this is where you compare the test statistic to the critical value. A second method that we'll also be looking at later today is called the p-value method. And this is where you find the probability of getting your particular test statistic or a more extreme value from your sample data. Keep in mind, all three methods will lead you to the same conclusion. A final method is to take something we've already discussed, confidence intervals, and the way you use that with a hypothesis test is you check to see if the population value is within your interval, and you can then make a conclusion from there. Now, as I mentioned, we're going to start by focusing on the traditional method. And so the steps that we'll be using for that is we'll start by stating our null and alternate hypothesis. Then we'll use our sample data to calculate a test statistic. We'll use the significance level alpha to determine a critical value. And then we will decide whether we'll be rejecting or failing to reject H naught. So the rule will be we're going to reject H naught, the null hypothesis, if our test statistic falls in the critical region or is beyond the critical values. Otherwise, we're going to fail to reject H naught because our test statistic is not in that region or not beyond the critical values. And as always, we end by stating a final conclusion, which is a complete sentence that lets somebody know our conclusion and the item that was being tested. So to begin, we'll want to be able to calculate the test statistic and critical values for a hypothesis test about a mean with the population standard deviation known. First, discussing the test statistic, which I'm going to be abbreviating as TS from here on out. This is the value calculated from the sample data which is used to determine if the claim should be rejected or failed to reject. So here is our formula for the test statistic. We take our sample mean and subtract it from the population mean to find that difference, but we want to divide it by the standard deviation. But remember, since we're using a sample size, standard deviation needs to be adjusted and itself needs to be divided by the square root of the sample size. For our test statistic, I'll always be answering two places after the decimal. And remember too that if you do not enter the whole formula into your calculator at once, which I'll show you when we get there, and you want to do intermediate steps, always use a minimum of 5 places after the decimal to avoid round off error. Okay, so and for the critical value, since sigma, the population standard deviation is known, is pre-existing, we will be using the z-table for the critical values. And don't forget that the z-table finds area to the left of a critical value or a z-score. So if we have a right tail test, then our table would give us the area in the opposite direction, and we would need to adjust it by looking up a value and then taking, let me rephrase that. We would need to find 1 minus alpha to go into the table first, or if we just looked up alpha, we're going to end up getting a negative z-table, a negative critical value, but for right tail tests, we would want the positive number, and you'll see all that worked out.